Sum of the year's digits is another declining charge method. Totally optional. I just put it in here in case you run into it. You should at least know what it is. I'm not going to test on it. It's actually okay for US GAAP and IGAP, but it can't be used for taxes in the US. Okay. So basically what happens is if you have a 10-year item, you have to say, okay, you add 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and you get 55, and that's the sum of the year's digits. Okay, that's fine if you've got a 10-year life. What if you've got a 50-year life? You're going to go 50, 49, 48. Okay, so why I even bother to do this at all is because there was a kid sitting in math class, and he came up with this formula to come up with that sum. So if you go n, so the number of years 10 times 10 plus 1 divided by 2, that gives you the sum of the year's digits. Okay, so it was Carl Friedrich Gauss who came up with this formula. He was taking a test in school. He was 10 years old. How do people do that? Oh well. Okay, so sum of the year's digits, it starts out like a straight line or your units of activity, cost less salvage, depreciable base. But then you take that 300,000 depreciable base, and the first year you multiply it by 10/55. That's the sum of the year's digits, and you start off with 10 because it's a 10-year life. And so this is your depreciation expense for year one. Next year you'd go 9, 8, 7, 6, 5, 4, and so on forth, so that it's a declining charge method. Okay, you don't have to know that. This is the only reason I talk about it at all. All right. What you do have to know about, though, is the group or composite depreciation. And so far what we've done is really on an individual basis, but the group or composite, you're depreciating a group of assets that are similar in hopefully type and service life, maybe a fleet of trucks, a fleet of cars, a bunch of machines that are about the same. Or composite, which is dissimilar assets with different useful lives. And as they point out, that saves a lot of work, but it's not particularly accurate. And so the depreciation is just in a single account, and you've got a rate that's based on sort of the average life of all the assets. And these are the only confusing part of this. You have to know these two, and it just takes some time to figure them out. You're going to take the straight line depreciation expense total, divided by total of the assets involved, and that gives you the rate. Then you take the depreciable base, cost less your salvage, and divide that by the total depreciation expense, and that gives you your composite life. And so generally in these questions you'll be asked for both the depreciation rate and the composite life. So let's see what that looks like. So if you've got three assets, you have to do something like this for them. You have to say, okay, this is the total cost, here's the salvage of each, here's their lives, and then the depreciation expense. So you're going 70 minus 7 divided by 10 gives you the depreciation expense, 50 minus 5 divided by 5, depreciation expense, and so forth. And so then, composite depreciation rate, total depreciation expense, divided by the total asset cost. And so that gives you your 21.8 divided by 202, which gives you your the rate there, the total composite depreciation rate. So they'll ask you for that. The other thing is the composite life. And there you've got your depreciable base, which is the 202, whoops, minus the 16, okay, so 186, divided by your total depreciation expense of 21.8. So your average, your composite life is 8.53 years. So that takes a little work to get down, but it's not, I mean, it's not like doing capitalization of interest. So, I mean, things could be worse.